Hi class, welcome back. Real quick, we're going to do a introductory to linear regression. We kind of seen it a little bit in the other course, in the other sections, but let's do a quick formal introduction. So, the definition of linear regression can be defined as a technique used to model the relationship between observed variables. So what I mean by this is that we already have data collected and we have graphed it, and now we're trying to find what kind of relationship do we have between x and y, for example. And then the goal is to best fit a linear function that represents the relation between the two observed variables. So moreover, the way we're going to define the relationship is by creating this function, and this function in this case, in this section, is referred as linear regression. So we're hoping that this relationship is a line, or we assuming this relationship is going to be a line, a straight line. So a straight line, remember that it looks like this: y equals mx plus b, right? Where we have a slope and we have a y-intercept. All right, so this is the y and this is the x, and all these points are x's and y's, right? And so this line does not go through every single point, but this line best fits the relationship. Now there is a whole mathematical formula process that goes behind the scenes to generate this line that best fits this data set. But we're not going to go through that in this course. That's a whole statistics course. What we're going to do in our classes, we're going to be using Excel to generate this line. All right, so this line best fits means that it is the closest to the given points, x and y. In other words, the best fit to the relationship, right? It's not closest to the points, but it's the best one that fits the relationship, right? That's how you want to see it. Once we have that line, we can use this to make predictions between the given set points. So we can say that between where we started from, right here, to here, we can make further predictions. For example, I can say, well, what about if x equals, let's say 13? Then what we can do is we can find what's x equals 13. We're going to say, okay, we can use this line to tell us what y value this will be, right? If we don't know this value, we can use the y to help us predict. Of course, this is just a prediction, so predictions are not 100%, but it is the one that best give us a prediction. All right, so the next part we want to talk about is the correlation. The correlation is the function given by the regression analysis. What I mean by the function? Well, the function in this case is a straight line, right? The linear function, right? This is your function. And the regression analysis is what happens behind the scenes, right? How we generated this straight line, which again, we're not gonna do in our class, but we're gonna use the Excel to do that. So the function given by the regression analysis will often fit some kinds of data better than others. This can be used to analyze the correlation between the variables. So that means that we have a determinant, what we call is called correlation coefficient value, that will tell us how two variables correlate to each other, right? And the correlation of this can give us some kind of information whether one variable depends on the other, right? The one can cause the other one, right? And that could be a information that we can look into. So the correlation coefficient value is between -1 and 1. So the numbers that we're going to be getting from this correlation coefficient will always be between -1 and 1. The stronger the correlation between x and y, and a positive slope, linear slope, then the closer the correlation coefficient is to 1. For example, this one, if you notice, this one has a strong correlation because the points are really near this line, but and also they're very close to this line. They're not scattered throughout they're not scattered throughout the whole thing, right? They're very much along this line. but then if you notice the slope of this line is positive, right? How would it look negative? This will be negative, right? That it goes in that direction. So that means that the correlation is 1, right? It's closer to 1. It's not 1, but it's close to 1. It could be, 0.89, 0.92, the stronger the correlation with a negative linear slope, then the closer the correlation coefficient is to -1. So in that case, if we actually had our line going this way, right, then the correlation number coefficient would be closer to -1. So for example, negative 0.76 or negative 8.2. Now, how do we calculate those correlation values? We're also going to use Excel to help us find those correlated values. And then lastly, the closer the value has to no correlation, then that means the correlation coefficient will be closer to 0. So this would mean if the number is really, all the data is really scattered throughout the thing, there's no pattern going on. So there's no pattern, that means there's no correlation. So then that means the number will be really close to 0. It could be negative 0.10 or positive 0.10, right? It's just, we really don't know. Again, the numbers in Excel will help us find those. So that's it for linear regression. This is a quick